Hi everyone, welcome to Numeric Learning. In today's video, let us solve NCERT Exercise 2.1 of the chapter Polynomials. Let us read the question clearly and try to understand as to what you need to know in order to solve this kind of questions. The question is, the graph of y equal to p of x are given here. Okay, so the graphs of y equal to p of x is given below. For some polynomials p of x. So what is p of x? P of x is a polynomial. Find the number of zeros of p of x. Now before we solve this, let me tell you a brief about what you need to know. Right? So here y is equal to p of x is given. What do you mean by p of x? P of x is a polynomial with variable x. Okay. Now there are different kinds of polynomial. Based on the degree, you have multiple types of polynomials. One type of polynomial is called the linear polynomial. Linear polynomial. Okay. Now linear polynomial, just an example, you can write it as y is equal to ax plus b. This is a linear polynomial. So what do you mean by a linear polynomial? A polynomial wherein the highest power of the variable is 1. So what is the power of x here? X is 1. So the degree of the polynomial is 1. If the degree is 1, it is called a linear polynomial. Always remember. Okay. If the degree is 2, for example, if I am writing y equal to ax square plus bx plus c. Okay, so here what is the highest power of the variable? Variable is x. Okay, so a, b and c are all constants or coefficients. C is a constant, a and b are coefficients. So what is the highest degree or highest power of the x, highest power of the variable x? That is 2. So if it is 2, then that means you can say that the degree is 2. And if the degree of a polynomial is 2, you call that polynomial as a quadratic polynomial. Okay. And if the highest power of the variable in a polynomial is 3, right? So it is say x square plus c. If the highest power of the variable is 3, then you can say the degree of this polynomial is 3. Hence, therefore, it is a cubic polynomial. Okay. And how do you find? So if you are given a polynomial and if you are asked to identify what is the degree, just make sure you understand what is the power, what is the highest power of the variable. Whatever is the highest power of the variable, that is the degree. And if the degree is 1, it's a linear polynomial. If the degree is 2, it's a quadratic polynomial. And if the degree is 3, it's a cubic polynomial. Now another thing that you have to know is, if it is a linear polynomial, that is of degree 1, okay, the maximum number of values of the variable that can give you the polynomial value as 0, that is only 1, maximum 1. Let me explain it here. Suppose you have p of x is nothing but x minus 3. Okay, so what is the degree of this polynomial? Degree of the polynomial is 1, because the highest power of x is 1, and if highest power of x is 1, the degree is 1, and if degree is 1, it's a linear polynomial. Now, what is that value of x, which when substituted will give the value of the polynomial as 0? So if you equate this to 0, right, x minus 3 equal to 0, then x equal to 3. Now, if you substitute x as 3 minus 3, it is 0. Okay, so 3 minus 3. So, what is that variable value which when substituted will give you a 0? It is x equal to 3. Now, this 3 is called the 0 of the polynomial. It is called the 0 of the polynomial. Okay. Now, is there any other value of x which when substituted here in place of x will give you a 0? No, it is not possible. It is only 3 when substituted will give you a 0. P of x as 0. So 3 is the only 0 of this polynomial. Okay. Now, because the degree is 1, Okay, always remember, if the degree of a polynomial is 1, the maximum zeros of the polynomial will be 1. That means there will only be one zero. If the degree of the polynomial is 2, the maximum number of zeros of this polynomial will be 2. Maximum 2, it can be less than 2 also. And if the degree of the polynomial is 3, then the maximum number of zeros of this polynomial will be 3. Maximum, or you can also say at most. It cannot be greater than 3. Okay, so how do you say, when you have a polynomial, how many maximum zeros it can contain? You can say that with respect to the degree of the polynomial. And how will you know the degree? When you correctly calculate the highest power of the variable. So degree is nothing but highest power of the variable will give you the degree. And with degree you can definitely say if it is a linear or quadratic or cubic or biquadratic polynomial, and how many maximum zeros it can contain. Okay, so this is what is the prerequisite in order to do this question. Now in this question, always remember, you have to find the number of zeros. What do you mean by number of zeros of p of x? That means the number of values of x that can make p of x 0. Okay, so whenever you see this graph here, right, these all the graphs are nothing but they are the graphs of the polynomial. They are polynomials that are given in the graphical form. Okay, and in order to find the number of zeros of p of x, you have to see in how many points does the line or a graph cut the x-axis. So if you see in the first question, it does not cut the x-axis at any point, right? It does not cut. So here the number of 0 is going to be 0. In the second one, see, look at the graph here, right? This is your polynomial graph. The number of points at which it cuts your x-axis is only 1. That means the number of zeros is going to be 1. In the third one, the graph cuts the x-axis at 1, 2 and 3. So the number of zeros here will be 3. Here in the fourth graph, it cuts x-axis, the polynomial graph cuts the x-axis at 2 places. In the fifth one, it's 1, 2, 3, 4. So the number of zeros of this polynomial will be 4. And here you can even if it touches the x-axis, that is also a 0. So 1, 2 and 3. So here the number of zeros of p of x will be 3. So it's very, very easy to calculate. Okay, always remember the number of points that it cuts or touches the x-axis, the graph, okay, that many zeros it will contain. Okay, so hope you understood. This was exercise 1. This was exercise 2.1. We will be solving exercise 2.2 of NCERT. The chapter's name is Polynomials. But before we start solving this exercise, we need to know certain things which I will be telling you now. The very first thing is we need to know what is a quadratic polynomial. Okay, so quadratic polynomial is something which is written in the form of ax square plus bx plus c, where this x is called as the variable. X is called the variable. Variable means the value will keep changing. And a, b and c, these are called as coefficients. A, b, c, these are called as coefficients. Okay, and c specifically is called as a constant. Constant means the value does not change. Okay, so x is the variable, a, b and c are the coefficients, but c is the constant. Now if you look at the variable, which is x, what is the power of x here? It is 1. What is the power of x in the first term? It is 2. So what is the highest power of the variable? It is 2. Okay, the highest power of the variable is 2. So the degree of this particular polynomial will be 2. And whenever the degree of a polynomial is 2, it is called as the quadratic polynomial. If the degree is 1, it is called linear polynomial. If the degree is 3, it is called the cubic polynomial. But in our syllabus, class 10th polynomial syllabus, you only have quadratic polynomial. So we will only be dealing with quadratic polynomial, which is of degree 2. Okay, and A, B and C are coefficients, or C is called the constant. What is the coefficient of x square? It is A. What is the coefficient of x? It is B. And what is the constant? It is C. Okay, so let me write that here. The coefficient of x square is nothing but A. What is the coefficient of x? What is attached to x? It is nothing but your B. And what is the constant term? Constant is denoted by C. Okay, so these are the coefficients. These are called the coefficients. Now, whenever you have a polynomial of degree 2, okay, it will have maximum of 2 zeros. Maximum of 2 zeros. What do you mean by 0? 0 of a polynomial. What do you mean by 0? Zeros are nothing but maximum 2 zeros. It is that value of x, a value of x which when substituted, the polynomial value will become 0. What should we substitute in place of x such that the entire polynomial value becomes 0? That value of x which makes the polynomial 0, that is what is called the 0 of a polynomial. And maximum you will have 2 zeros. Okay, in a quadratic polynomial of degree 2, the maximum number of zeros that will exist is 2. It can be less than 2, but the maximum is 2. Remember this. Okay, so what is the maximum number of zeros in a quadratic polynomial? It's going to be 2. Now these zeros can be written as one is alpha, the other one is beta, just a representation. Okay, so one of the 0, let it be alpha, the other 0 is beta. That means whatever be the alpha value, if I substitute the alpha value in place of x, then this value of the polynomial will become 0. That is why it is called alpha is called a 0 of the polynomial. Whatever be the beta value, say 1, 2, minus 1, 1 by 2, 3 by 2, whatever be the beta value, if I substitute in place of x, again it's going to be the value of the polynomial p of x will be 0. Okay, so we will denote this polynomial by say p of x. What do you mean by p of x? It's a polynomial with variable x. So this is what is the polynomial, quadratic polynomial with variable x. Okay, now an important thing to remember is what is the relationship between the coefficients and the zeros. The relationship between the coefficients and the zeros. Okay, let me write it here. Relationship between the coefficients and the zeros. Okay, I am directly going to write the relationship, the sum of the zeros. Okay, the sum of the zeros. What is the zeros? Alpha and beta are the zeros. So the sum of the zeros will be alpha plus beta will always be equal to minus b by a. Okay, what do you mean by minus b by a? Minus is along with the formula you have a minus. So minus b by a. What is b? B is the coefficient of x. And what is a? A is the coefficient of x square. B is the coefficient of x and a is the coefficient of x square. Okay. Now, this is the first thing that you have to remember. Okay, let me put this in a box. That is, the sum of the 0, the formula is minus b by a. Similarly, there is another. So here, if you see, it is a relationship between alpha, beta and b and a. So alpha, beta are the zeros and b and a are the coefficient. So there is another relationship, one that is nothing but the product of the zeros. The product of zeros. Product of the zeros means alpha multiplied by beta is always equal to c by a. This is another formula that you have to relate, the relationship that you have to remember. The product of the zeros And that is alpha multiplied by alpha into beta is equal to C by A. What is C? C is nothing but your constant. And A is nothing but the coefficient of x square. Okay. So if you know these two, this knowledge is what you need, or this formula is something which you should know in order to do this exercise. See what is given here. Find the zeros of the quadratic polynomials and verify the relationship between the zeros and the coefficients. Okay, first of all we have to find the zeros, that is alpha and beta we have to find out, and then we also have to verify the relationship between, we have to verify whether alpha plus beta is really equal to minus b by a, whether alpha multiplied by beta, alpha into beta is equal to c by a. We have to verify and we have to show. Okay, so let us do the first question. The first question is x square minus 2x minus 8. Okay, so let me write it here. The first question, x square minus 2x minus 8. Now again, the minute you have the quadratic polynomial, we have to compare it with the standard quadratic polynomial, which is ax square plus bx plus c. So on comparing, if you see here, the coefficient of x square is nothing but it's just 1. What is the coefficient of x along with the sign? Minus 2. What is the coefficient of c? What is the constant c? It is minus 8. So let me write it here. So on comparing, we get a is nothing but the coefficient of x square, which is 1 in our question. So, okay, a is 1. What is b? Minus 2. B is nothing but minus 2 and c is nothing but your minus 8. Okay. Now, we have to find the zeros of it, isn't it? So, you have to factorize it. So, we have to factorize it using middle term splitting. This is a method. Middle term splitting. I will tell you what it is. Okay. So the given polynomial, let us write the given polynomial x square minus 2x minus 8 equal to 0. Okay. Because we are finding out the zeros, let us equate it to 0. Always remember, there are two things here. One is the sum and the other one is the product. The sum is nothing but your b. B is nothing but your sum. Okay. So what is b here? Minus 2. Let me write it. So b is nothing but, this is your b, and the product is nothing but a into c. So you have to first pick up what is the sum and what should be the product. Okay. What is the sum? Sum is nothing but your b. So b is minus 2. Minus 2. Product is nothing but a, that is a is nothing but the coefficient of x square. Here it is 1. 1 into minus 8. A into c. Okay, so this is a and this is c. So let me write it here. 1 multiplied by minus 8, which is nothing but minus 8. Now you have to find two numbers whose sum is minus 2 and whose product is minus 8. What are the two numbers? How will you find it out? Do the prime factorization of 8. Okay, so you see 2 4s are 8, again 2 2s are 4. And see multiple combinations. 2 into 2, 4 into 2. So 4 2s are 8. So 4 and 2. If you multiply 4 and 2, you will get 8. If you add it up, you should get minus 2. So I will put a negative sign here in minus 4. Okay, so minus 4 and plus 2. See, you can verify it. Minus 4 plus 2 will give you minus 2 and minus 4 into 2 will give you minus 8. Okay, so minus 4 and plus 2. Now, using these are the two values that you have to substitute in order to do the middle term splitting. So, I am going to write x square. Instead of the middle term minus 2x, I am going to write minus 4x plus 2x. Yeah, because minus 4 and plus 2. These are the two numbers whose sum is minus 2 and whose product is minus 8. Okay, so minus 8 equal to 0. Take x common out from the first two terms. So x minus 4 plus 2 common out. Again x minus 4 equal to 0. Okay, so between these two terms, you have x minus 4, take it out common. The remaining is x plus 2 equal to 0. Okay, so whenever product of two terms is equal to 0, either the first term is 0 or the second term is 0, isn't it? So either x minus 4 equal to 0 or you have x plus 2 equal to 0. So x is equal to minus 2 is one value of x and x is equal to 4 is the another value. So these are the zeros of the polynomial. These are nothing but the zeros of the given polynomial. So let one of them be alpha, the other one let it be beta. Okay, so now we have got the zeros. So what was the question here? Find the zeros of the quadratic polynomial. Find the zeros of the following quadratic polynomial using factorization with middle term splitting. We have found out the factors of the first polynomial and verify the relationship between the zeros and the coefficient. So now let us verify the relationship. Okay, so let me write it here. Let alpha is nothing but 4. Your beta is nothing but minus 2. These are the zeros of the given polynomial. Okay. Now let us verify the relationship. What is the relationship? First of all, the sum of the zeros alpha plus beta should be equal to minus b by a. And alpha into beta should be equal to c by a. Okay. So alpha plus beta. What is alpha? 4. Plus what is beta? Minus 2 is equal to what is minus. So minus, this minus is the formula's minus. What is the value of b that we have in the question? B is minus 2. Okay, so b is nothing but minus 2 divided by a is 1. In our case a is 1. Okay, so let me copy this and put it here so that it's easier for us to do it. Okay, so this is these are the a, b, c coefficients that we have, right? So now what is 4 plus into minus is minus 2 equal to minus into minus is plus, so it's 2. So 4 minus 2 is equal to 2. Hence verified, right? Now we have verified that yes, the sum of the zeros is equal to minus b by a. Now let us see the product of the zeros. What is alpha? Our question 4. What is beta? Minus 2. Should be equal to c by a. What is c? Minus 8 by a is 1. So 4 into minus 2 is minus 8 equal to minus 8. So hence verified. Okay, so therefore alpha beta is equal to c by a and alpha plus beta, the sum of the zeros is equal to minus b by a. Hence verified. Hence verified. So this completes your first question. I hope you understood. All the other questions are of the same format. Now let us do the second question. What is the second question? 4s square minus 4s plus 1. Okay, so let us do that. The second question. Okay, the second question is 4s square minus 4s plus 1. Okay, as I told you, you have to compare it with the standard quadratic polynomial that is of the form ax square plus bx plus c, where a is the coefficient of x square. It's just in place of x you are given s, that's all. So what is a here? A is nothing but your 4. What is b? The coefficient of x or the coefficient of s is minus 4 and your c is nothing but 1. Okay, so now again the very first thing to do is we have to factorize it. You have to do the factorization using middle term splitting. So let us do using middle term splitting. Using middle term splitting the same way as we did in the first question. So 4s square minus 4s plus 1 equal to 0. Because you are finding the 0, you have to equate it to 0. What is the sum and what is the product? The sum is b. And what is b? It is minus 4. minus 4 is the sum. What is the product? A into C. Okay, so 4 into 1, which is 4. Now you have to tell me two numbers whose product is 4 and whose sum is minus 4. So you have got 2 into 2. 2 twos are 4. And where should I add a negative sign such that the sum is minus 4? It is minus 2, minus 2, it is minus 4. Okay, and minus 2 multiplied by minus 2 will be plus 4. So let us do the middle term splitting. So we have found out the two values, right, for middle term splitting. So replace it 4s square minus 2s plus 1 is equal to 0. From the first two terms, take out common. 2s is common. So 2s minus 1. Again minus 1 common out. 2s minus 1 equal to 0. So among these, the first and the second term, let's take 2s minus 1 is common. What is remaining is also 2s minus 1 equal to 0. Okay. So as usual, either 2s minus 1 is equal to 0 or 2s minus 1 equal to 0. So 2s equal to 1 and s is equal to 1 by 2. Okay. So this is one of the zeros. And the other one is also the same, s is equal to 1 by 2. It's the same thing, right? So let one of them be alpha and the other one is beta. Okay. So we have got alpha is nothing but 1 by 2. We have got beta is also equal to 1 by 2. Okay. And we have got the coefficients. What is A? What is A? A is nothing but 4. A is 4. What is B? B is minus 4. And what is C? According to the question, C is nothing but 1. Okay. So these were the, what is alpha and beta? These are the, so you have found the zeros of the polynomial. Now let us verify the relationship. In order to verify, first of all, let us see if the sum of the zeros is equal to minus b by a. What is alpha? 1 by 2. Plus what is beta? Also 1 by 2. It should be equal to minus b. B is minus 4. By a. A is 4. Okay, so minus into minus is plus 4 by 4, which is equal to 1. That is your RHS. In your LHS, what will you have? Take the LCM is 2. So 1 plus 1. So 2 by 2 is also 1. Right? So we have verified. The second part, whether the product of the zeros is equal to C by A. So what is alpha? Just replace 1 by 2 multiplied by 1 by 2 should be equal to C by A. C is 1 divided by A is 4. Yes, 1 by 2 into 1 by 2 is 1 by 4 is equal to 1 by 4. So hence verified. Hence verified. So we have done the second question the same way. Okay. Now let's move on to the third question. The third question is nothing but 6x square minus 7x minus 3. Okay. So let's do the third question here. Let me bring down the question again for you. So the third question is 6x square minus 7x minus 3. Let's do it the same way. We have to compare it with the standard quadratic polynomial, that is ax square plus bx plus c. So what is A? A is 6. What is B? Is minus 7 and C is nothing but minus 3. Let's do the factorization using middle term splitting. So 6x square minus 7x minus 3 equal to 0. So what should be the sum and what should be the product? Sum is nothing but minus 7. That is your B. And your product is 6 multiplied by minus 3. 6 into minus 3 is minus 18. Okay. So if you see, how do you find out what are the two values whose sum is minus 7 and whose product? Take the prime factorization of 18. Okay, so here you say 2 9s are 18, again 3 and 3. Take multiple combinations. 3 into 2, 6 and 3. 6 into 3 is 18, but 6 and 3 cannot be added up to get a sum of 7. So let us try with some other number, some other combination. Okay, so here if you take 3 into 3, 9 and 2. Okay, 9 and 2. Yeah, definitely you will get a minus 7 if you put a minus sign to the greater number. So minus 9 into 2 you will get minus 18, and minus 9 plus 2 you will get a minus 7. So these are the two values for splitting the middle term. So let us do that. 6x square minus 9x plus 2x minus 3 equal to 0. Okay, so between the first two terms, let's take 3x common out. So 2x is the first term minus 3 plus 1, 2x minus 3 equal to 0. So you have 2x minus 3 among the first two terms. The remaining is 3x plus 1 equal to 0. So either 2x minus 3 is equal to 0 or 3x minus 1 is equal to 0. So these are the two values of x, which when substituted in our given quadratic polynomial will give you the value of polynomial as 0. So 2x equal to 3 and x is nothing but 3 by 2. Okay, so this is the first value. This is your, let it be alpha. And the other value is 3x equal to 1 and x is nothing but 1 by 3. So this x value, let it be your beta. Okay, now let us verify the relationship. So what have we got? We have got the zeros as alpha equal to 3 by 2 and beta equal to 1 by 3. And what are the coefficients? Coefficients of the given quadratic polynomial. What is A? A is nothing but 6. B is nothing but minus 7. And C is nothing but, what is C? Minus 3. Now let us easily verify our relationship between zeros and the coefficients. So alpha plus beta is equal to minus B by A. What is alpha? 3 by 2 plus 1 by 3. Let us take the LCM 6. So 2 into 3 is 6, 3 into 3 is 9. Plus 3 into 2 is 6, 2 into 1 is 2. So what are you getting? Is it correct? Have I done it correctly? Okay, I have made a mistake. The mistake is nothing but, see, 2x minus 3 equal to 0 or 3x plus 1 equal to 0, isn't it? So this is 3x plus 1. Let me correct it. So what will be x here? X will be equal to minus 1. Okay, so here a small correction to be made. So 3x equal to minus 1 or x is nothing but minus 1 by 3. Okay, so that is your beta value. So beta value is minus 1 by 3. Okay, so now let me do this correction here as well. So what is beta? It's not 1 by 3, it is minus 1 by 3. Minus 1 by 3. Now let's take the LCM, it's 6. So you have 3 3s are 9 minus 2, which is nothing but your 7 by 6. Okay, and what is your minus? What is your B? Minus 7 divided by A is 6. Okay, so minus into minus is plus, 7 by 6. Okay, so 7 by 6 equal to 7 by 6, hence verified. Now let us take the other relationship, that is alpha into beta should be equal to C by A. Okay, so what is alpha? 3 by 2 multiplied by beta is minus 1 by 3. Okay, so 3 and 3 gets cancelled, you will get minus 1 by 2 in the LHS. Minus 1 by 2. What is C? C is minus 3 divided by what is A? 6. So again, if you cancel, 3 ones are 3, 3 twos are 6. So you'll have a minus sign already, so it's minus 1 by 2. Hence verified. Okay, so we are able to show that the sum of the zeros, what are we able to show? The sum of the zeros is equal to minus b by a, and the product of the zeros is equal to c by a. We are able to prove the relationship between the zeros as well as the coefficient. The relationship between the zeros and the coefficient. Okay. So let's move on to this. So we have done 3 questions now. Let us move on to the 4th question. What is the 4th question here? 4u square plus 8u. It's again very easy. Let's do it. 4u square plus 8u. Right? You have to compare it with ax square plus bx plus c. Okay, so instead of x you are given u. So what is a here? A is nothing but the coefficient of u square, that is 4. What is b? The coefficient of u, which is 8. And c, you don't have a constant, so c is nothing but 0. Okay, now here you don't have to do a middle term splitting, or you can easily factorize it by taking out common. So 4u square plus 8u equal to 0. So among these two terms you can take 4u common out. So you will have u plus 2 equal to 0. So either 4u equal to 0 or u is equal to 0. Okay, so this is your alpha. And then another value of the 0 is nothing but u plus 2 equal to 0. So u is equal to minus 2. Okay. So this is your beta value. So you've got one alpha and one beta. So let's find the relationship. Okay. So alpha plus beta should be equal to minus b by a. What is alpha? 0. Plus what is beta? Minus 2. So you're getting minus 2 here. What is minus b? Minus b is nothing but your 8 divided by what is a? It is 4. So what is here? What do you get? Minus 8 by 4 is minus 2. So this is equal to minus 2, hence verified. Same way, product of the zeros, alpha beta should be equal to c by a. What is alpha? 0. 0 into beta is minus 2. Should be equal to what is c? C is 0 by 4. Okay, so 0 is equal to 0, hence verified. Always do write hence verified. Okay, now let us move on to the next question. T square minus 15. Okay, okay. The next question is t square minus 15. So that's your 5th question. T square minus 15. Very easy. The same way, let's compare it with the standard quadratic polynomial ax square plus bx plus c. So what is your a? A is 1. That is the coefficient of t square. What is b? You don't have a t here. You don't have a t term. So b is 0. And what is c? Minus 15. Okay, so let us do a t square minus 15 equal to 0. So what is t square is equal to 15, and what is t? T is equal to plus or minus root of 15. Okay, so that is your value of the variable, which are nothing but zeros. So either t can be equal to plus root 15 or t is equal to minus root of 15. So one is your beta and one of the 0 is your alpha. Now let us verify the relationship. So alpha plus beta should be equal to minus b by a, and alpha into beta should be equal to c by a. So let us do that. Alpha is nothing but your root 15 plus what is your beta? Minus root 15. So you have root 15 plus into minus is minus root 15, which is nothing but 0. Okay, what is minus b? Minus 0 divided by what is a? It is 1, which is also equal to 0. So 0 equal to 0. Alpha multiplied by beta. So what is alpha? Root 15 multiplied by minus root 15. Okay, should be equal to what is c? C is minus 15. What is a? A is 1. Okay, so what is root 15 into root 15? It is 15, and you have a negative sign. So minus 15 equal to minus 15, hence verified. Hence verified. So you have again verified the relationship between the coefficients as well as the zeros of the polynomial. Okay, so we have done the fifth question as well. Now let us do the last question of the first. Okay, so last question. What is the last question? 3x square. So we have completed these 1, 2, 3, 4 and 5. Let's do the last one. The sixth question under question number 1. 3x square minus x minus 4. Again, let's compare it with the standard quadratic polynomial ax square plus bx plus c and get what is a. A is nothing but your 3. B is nothing but minus 1. Be very careful with the signs also. And c is nothing but minus 4. Okay, so c is nothing but minus 4. B is the coefficient of x along with the sign, that is minus 1. And a is nothing but 3. Okay, now again, here also we have to do the factorization to find the factors or the zeros of the polynomial using middle term splitting. So again, let me write using middle term splitting. Okay, 3x square minus x minus 4 equal to 0. Okay, so what should be the sum and what should be the product? Sum should be minus 1, right? B which is minus 1. And what should be the product? A into C. Okay, so 4 into 3 into minus 4, which is minus 12. So the minute you see this, you have 4 and 3. 4 3s are 12. And if you put a negative sign to the bigger number, you will get a minus 1. Minus 4 plus 3 is minus 1. Minus 4 multiplied by 3 is minus 12. So that is your middle term splitting. So let me cut this. Let's finish this so that, okay, so here you have got 3x square minus, the middle term is minus 1 is split up as minus 4 and 3. So minus 4x plus 3x minus 4 equal to 0. So here you can take x common out. 3x minus 4 again plus 1 common out. 3x minus 4 equal to 0. So taking common, you have x plus 1 and the other term is 3x minus 4 equal to 0. So either x plus 1 equal to 0 or 3x minus 4 equal to 0. Okay, so here you have x is equal to 4 by 3 and here you have your x equal to minus 1. Okay, so let this be our alpha and the other one be your beta. So what are these? These are the zeros of the polynomial. These are the zeros. That means if you substitute in place of x, if you substitute minus 1, you will be getting the polynomial value as 0. If you substitute 4 by 3 also, the value of the polynomial will be 0. That is why it is called the zero of the polynomial. Okay, now let us verify the relationship. Alpha plus beta is equal to minus b by a. And alpha into beta is equal to c by a. So what is alpha? Minus 1. What is beta? Plus 4 by 3. Take the LCM 3. So you'll have minus 3 plus 4. What is 4 minus 3? It is 1 by 3. Okay. So what is minus b? What is your b here? Minus 1. So minus of minus 1 whole divided by what is your a? A is 3. Isn't it? So minus into minus is plus, again 1 by 3. So 1 by 3 is equal to 1 by 3, hence verified. What is alpha into beta? What is alpha? Minus 1 into, what is your beta? 4 by 3. So it's minus 4 by 3 is equal to, what is c? C is again minus 4. Minus 4 by, what is your a? A is 3. Okay, so it is nothing but again minus 4 by 3, hence verified. So we have done 6 problems under this particular exercise. Okay, so whenever you are given, whenever you are asked to find the zeros of the quadratic polynomial, always remember to go for factorization. First find the zeros of the polynomial and then verify the relationship between the zeros and the coefficients using this. Alpha plus beta equal to minus b by a. Alpha into beta equal to c by a. Now let us go ahead with the second question of exercise 2.2. Here, find a quadratic polynomial each with the given numbers as sum and the product of its zeros. You are given, you have to find a quadratic polynomial. You have to find the quadratic polynomial whose sum and product of zeros is given. That means the first value is the sum of the zeros and the second value is the product of the zeros. Let's go ahead and do the first one. It's again very, very easy. 1 by 4 comma minus 1. Okay. So what is 1 by 4? It is the sum of the zeros. And what is minus 1? It is the product of the zeros. There is a formula provided you know. Okay. Provided you know the sum and provided you know the sum and product of the zeros, you can have there is a formula that is nothing but you can easily find out the quadratic polynomial using this. That is k multiplied by x square minus the sum of the zeros, into x plus the product of the zeros. Okay, it's the product of the zeros. Okay, so k multiplied by, how will you remember it? X square minus sx plus p. S is nothing but the sum and p is the product. So let's just substitute. And you should also remember that there cannot be one polynomial whose sum will be whose alpha plus beta. Okay, sum means nothing but alpha plus beta is 1 by 4 and product of the zeros is nothing but alpha into beta is minus 1. You can have n number of quadratic polynomials with this 1 by 4 as the sum and minus 1 as the product. So you should always specify this letter k. K can be anything. K can be 1, it can be 1 by 2, it can be 1 by 4, it can be 2. So always mention k here. Okay, so let's substitute the value. So here you have k multiplied by x square minus what is the sum? 1 by sum of the zeros is 1 by 4 into x plus the product is nothing but your minus 1. Okay, so here let me rewrite it. K into x square minus 1 by 4x minus 1. Take the LCM. So you have k multiplied by 4 is the LCM. So you have 4x square minus x minus 4. Okay. So let k equal to 1. So if k equal to 1, what would you have? Take 1 by 4 outside. Okay, k is 1. So k is 1 and 4 you can take it out. Inside you will have 4x square minus x minus 4. So this is your answer. Okay. Now, if you are writing k is equal to 2, okay, or if you're taking k is nothing but 4, okay, if k is equal to 4, then 4 and 4 will get cancelled. This is your answer. So everything is correct. Okay, whatever be the value of k that you substitute, that answer is correct. It is not necessary that you also have to take k equal to 1. Remember it. Okay. Now let us go ahead and do the second problem. What is the second problem? Find the quadratic polynomial with the sum as root 2 and the product of the zeros as 1 by 3. So second question. Root 2 and 1 by 3. The same way let us do. So your sum is nothing but root 2 and your product of the zeros is nothing but 1 by 3. Okay, so k multiplied by the quadratic polynomial will be x square minus s into x plus p. Sum. Okay, so let's substitute k into x square minus root 2x plus 1 by 3. Okay, let's take the LCM. K into, take LCM as 3. So you have 3x square minus 3 root 2x plus 1. Okay, now you can take any value of k. I'm going to take 3. So let k equal to 3 so that I can cancel it out. So 3 by 3 multiplied by again 3x square minus 3 root 2x plus 1. 3 and 3 gets cancelled, and the given quadratic polynomial is 3x square minus 3 root 2x plus 1. So you just have to find a quadratic polynomial. See, look at the question. Find a quadratic polynomial each with the given numbers as the sum and the product. There cannot be, again I'm telling you, this is not necessarily the answer. You can substitute any value of k and everything is the right answer, but you have to solve it correctly. Okay, so we are done with the second question. Let's move on to the third question now. What is the third question? 0 and root 5. The same way, let us do it. Okay, so third, 0 comma root 5. So what is the sum? Sum is 0. Product is nothing but root 5. The polynomial is nothing but x square minus sx plus p. Let's substitute here k into x square. You will not have a second term because it is 0. So 0x plus root 5. So what is it? K square into x square plus root 5. Okay, so let k be 1. Let k equal to 1. So your answer will be x square plus root 5 is the required answer. Okay, so we are done with the third question. This is all you have to do. It's a very easy question. So if you know the sum and the product of the zeros, you can easily find out the quadratic polynomial. Let's move on to the fourth one. 1 comma 1. What is the sum? Sum is 1. What is the product? Product is also 1. What is the quadratic polynomial expression? X square minus sx plus the product of the zeros. So let's substitute k into x square minus 1 into x plus 1. Right? So let k be equal to 1. So your answer will be x square minus x plus 1. See how easy it is. You will be able to do it within a minute, right? Provided you know these, you should have solved these sums. So we are done with third also. Let's move on to the fifth one. And we are just done with fourth. The fifth one is nothing but minus 1 by 4 and 1 by 4. Okay. So what is sum of the zeros? Minus 1 by 4. What is the product of the 0? 1 by 4. And what is the quadratic polynomial expression? K into x square minus sx plus p. Okay. So k into x square minus, again the sum is minus 1 by 4 into x plus product is 1 by 4. Do it very carefully. There is a negative sign along with the formula. You have a negative sign, and s in the sum also, s also you have a negative. So be very careful. Okay, so k multiplied by, take the LCM 4. So you'll have 4x square plus again x plus 1. Okay, so here I'm going to take let k equal to 4 so that it gets cancelled. Let k equal to 4. So you will have 4 by 4 multiplied by 4x square plus x plus 1. 4 gets cancelled. So the answer is the required quadratic polynomial is nothing but 4x square plus x plus 1. That's your answer. Okay, now let's do the last problem. So this is nothing but the fifth problem, right? Let's do the sixth one. Sixth one is 4 comma 1, right? 4 comma 1. 4 and 1. So what is the sum of the 0? It is 4. Product of the 0 is 1. Okay, so the quadratic polynomial is nothing but k into x square minus sx plus p. So k multiplied by x square minus sum is 4 plus product is 1. So again, let k equal to 1. you'll have x square minus 4x plus 1 is your answer. This is the required polynomial, required quadratic polynomial whose sum of the 0 is 4 and the product of the 0 is 1. So very easy exercise to do, but make sure you do all of these questions so that if such questions come, you are able to do it. So you have to practice more and more. Okay. You should know if sum of the zeros and product of the 0 is given, how do you find a quadratic polynomial? That is one type of question. And the first question that we did was, if you have to find the zeros of the following, you have to find the zeros using either middle term splitting or by taking out common, and then also verify the relationship between zeros and the coefficients. So these were the two exercises. We solved nearly 12 problems. Make sure you do it. I hope you understood. One last thing that I would like to do is, if you are a student of class 10th and if you are interested in joining an online maths class, a structured maths class wherein I will be your mentor, I will be teaching you every chapter after chapter, and we will be doing daily exercise problems, do comment below. You will find the details for my online mathematics class in the description below. Do share, please do like and do subscribe. Happy learning. Thank you.